Now, we've been dealing with Matplotlib so far, right? Everything that we've been doing over here is coming from Matplotlib, right? This is just the power of core Matplotlib that we've been using, right? Without any other package built upon Matplotlib, right? Now let's go and use this Seaborn, which is also built on top of Matplotlib, which is quite efficient and makes the code quite simple, right? Remember, right from the NumPy class, when we started talking about list comprehension, I told you that the most important thing that you can actually do is to simplify your code, right? Or try as much as possible to make sure that your code is simplified. Okay, so let's talk about Seaborn and see how efficient Seaborn will help us to actually make our code simple, right? So some of the things that we might spend a lot of time doing in using just Matplotlib. If you use Seaborn, it takes care of a lot of things for you. Okay, so let's see how we're going to actually use this. Okay, so as I said, if you want to use any library, the first thing that you can actually do is to first import the particular library that you want to use. Okay, so in this case, we are importing Seaborn, right? We're importing Seaborn library, and then we are aliasing it to SNS, right? Or we are renaming it, or giving it a nickname as SNS, so that we will be using SNS right from here. Okay, so that one is done. Now what I'm going to do is to actually use a real data set to actually work with this, right? So over here we're just using some dummy data that we just create, right? And then we use it. Now I'm going to use a real data set over here. Okay, so I have this Pokemon.xls, right? So this is actually a data set which is in a SL format. Okay, so you can see that over here I'm using read_SL to read it, because my data set is an SL format, right? It's not a CSV format as we were dealing with in the Pandas or the NumPy class. Okay, in this case our data set is actually stored in an SL format, so I'm going to use read_SL, right? And this function is present in Pandas, right? I'm going to read it and then make sure that it's in a form of a data frame, right? That's rows and columns for us. Okay, so that's what I'm doing over here. Okay, so if we do that, we can actually visualize the first 5 rows using the head function, right? We can visualize. Remember that when we load the data, we are storing it in this variable called our data. Okay, and this variable could be any variable name. It could be just data, right? It could be it could also be maybe anything, any variable name that you want to actually create. Maybe my data, right? Maybe my data, anything like that. Okay, so let's maintain it as our data, right? So that's the variable that is actually containing all the data that we've loaded over here. Okay, and now we want to see the first five rows, right? And then get to see what is contained in the data that we've loaded. Okay, so if we do that, this is what we have name, we have type 1, type 2, total, HP, attack, defense, ATK, def, right, and speed, stage, legendary, right? So these are the data points that are present in this Pokemon.xls data that we just loaded. Okay, what we are interested in is, just use Seaborn over here to make some visualizations. Okay, so moving on, we will actually be dealing with different data sets that will come in different format, and we are going to actually see how we are going to work with all those. Okay, in this particular one, let's keep concentrated on what we want to do here, that is use the Seaborn to actually make some visualizations. Okay, now the first thing I'm going to do over here inside Seaborn, we have this function which is lmplot, right? So the lm is nothing but this linear relationship. All right, it's actually help you to plot a linear relationship between two variables, and the lm is this linear regression model, right? It stands for linear regression model. We will see this in the statistics class, right? We are going to see that, but it's actually nothing but just a regression model that you can actually use this function to actually express. Okay, we will be seeing that in the stats class, so no need to worry about that. Okay, just what you need to know is that this will help us to plot a relationship between two variables. Okay, so in this case you can see that I'm supplying x, right? And then I'm supplying it with one of the columns, right? So I'm supplying it with this attack, right? This attack data, that's what I'm supplying here as my X. And then with this Y, I'm going to use defense, right? So I'm going to use defense here, right, as my Y, as Y on my Y data. Remember what we were doing earlier on when we're using the Matplotlib, right? Up here we supply X, right? We supply one for X, and then we supply one for Y. So it's the same thing that we're doing here. Over here we could have even ignored this X, right? We could have just ignored this X, and then even this one, and then just do this. Okay, and then over here what we're doing here is that we are specifying that our data, right? So this data is actually a parameter that is present in this lm plot. Okay, so you specify where your data is coming from. So my data is coming from our data, which is this, right? Which is this that we loaded. So this column and attack and defense are present in this our data. So I'm specifying that this X and Y that I'm provided here are present in our data. Okay, now if we do that, right, if we do that, so now, don't forget that I'm using SNS here, which is Seaborn, right? So if I do that, you see that I'm able to plot this, right? I'm able to plot this. Now if it is Matplotlib, remember we did not do any X label or Y label over here, but still we have the labels, right? We have the labels. That's what SNS, Seaborn will help us to do, right? As simple as that. You don't need to be spending time doing all those kind of things. Okay, now we see that we even have the regression line, right? I told you that we talk about the regression. We talk about regression, right? When we are talking about the logistic regression and linear regression, we talk about in that in detail. But in the meantime, just see how Seaborn is actually helping us to actually plot this and then be able to see the relationship that is existing among this defense and then attack. So over here, you can see that we have a positive relationship, right? We have a positive relationship. Let me show you this one so that you can actually see what I mean by a positive relationship over here. So if you see this that you have on your screen here, right? We have this that is going up this way, right? That is going this way, which is a strong positive correlation, right? So if you have it this way, right, your scatter plot is actually plotting it this way, then it's actually a strong positive correlation, right? This one is also a positive correlation, but it's not as strong as this, right? As everything is actually trying to lie on the line. If you try to plot a line in between, you see that most of the points will lie on the line, right? If you try to plot a line of best fit, right, just the same thing that is actually doing here. Plotting a line, you see that it's positive, but it's low, right? It's actually low. That's why you see some of the data points scattered around over there, right? Scattered around over there. But if it is stronger like this, and you can draw a line where most of the data points are actually going to lie on the line like that, and then it's a strong positive correlation, right? It's a strong positive correlation. Now even this one, if you draw a line like this, though some of the points are going to be lying on the data point, but you can still see some of them that are a bit far from the line, right? Unlike this one where most of the points are clustered around the line. Okay, so this one, although it's a positive correlation, but it's moderate, right? Moderate positive correlation. Okay, now if you see this one, see how this one is also going down, right? It's going down. Let me actually shift it a little bit up for you. Okay, you see how this one is actually going down. Okay, now if you plot, if you do this, let me take this one off. Okay, if you do this and then you plot a line over here, right, you can see that some of the points are lying on it, irrespective of the fact that some are still lying a bit far from the line, right? So it's a negative, right? It's a moderate negative correlation, unlike this one, right? We'll see how this one is, right? So if I plot this line in between these, or to pass through the points, you can see that most of the points will fall on the line, right? So that becomes a strong negative correlation. Okay, so as against this one, which is a strong positive correlation, right? So going that way, this one is going this way. So this one is a negative, right? Negative correlation. This one is a positive correlation, right? So this is a strong positive, this is a strong negative. There's a moderate positive, right? It's a moderate positive, right? Moderate positive, and this one is a moderate negative, right? This one is a moderate negative. You can also have a correlation where you will not have any direction, or so this one is not neither going this way, right, and it's not also going this way, right? So it's not actually having any direction. Okay, you might also have, so in that case you have no correlation in there. You might also have a situation, right, a situation where you will be having something like this, right? So in this case we refer to as the curvilinear relationship, right? So whatever data points that you're trying to compare the relationship, we say that this relationship is curvilinear, right? You see how this is being displayed is curvilinear. Okay, so going back to what we were actually dealing with right before we came here, you can see that we have this regression line there. We have this regression line, although it's positive, but you can see some of the data points are, right? They are far away from this regression line. Okay, so this becomes a moderate, right? It becomes a moderate, right? A moderate positive, right? A moderate positive correlation. So you see how this LM plot, right, is actually helping us to do this. So it's just this single line of code, right? Just a single line of code. So if we are supposed to do this just with the Matplotlib, right? Just with the Matplotlib, then it's actually going to use a lot of lines of code, right? To even specify y label and x label, and specifying this line and others. I mean, it's actually going to be a long process, right? And but with Seaborn, just a single line of code, we can actually achieve that. Okay, so that's actually what the power that Seaborn will add on top of Matplotlib. Okay, that's what the power of Seaborn. Now let's see how with this one we have the regression line. Let's say we want to take away that regression line. We can also do that, right? So what you can actually specify to just take away that. So I'm using the same thing, SNS LM plot. I'm using the same thing. I'm supplying my X, I'm supplying my Y, right? What I'm doing different, and then my data is also there. What I'm doing different then is this fit underscore reg, right? So I'm saying that the regression line, right, whether I should fit it or not, right? If I don't want to fit it, I set it to false. If I want to fit it, I set it to true, right? So let me push this a little bit up, right? If I want to if I want to fit it, I set this one to true. If I don't want to fit it, I set it to false. Okay, so if I do that, you see that now I don't have any regression line in there, unlike what we were dealing with earlier on, right, where we have the regression line. Now if I do the fit reg equals true, equals false, I don't have it, right? By default, it's actually going to be there. I remember here I did not even specify it, so by default it is going to set to true, but manually you can set it to false so that it will be off. If you want to take it away. Okay, that's if you want to take it away, you can also do that. All right, now let's see what we can actually do. Now over here, what we did is that we compare the defense and then the attack. So this one is in a two-dimensional space, right? I'm just visualizing this in a two-dimensional space, right? Just in a 2D space. Okay, what if I want to if I have several data points and I want to do it in a three-dimensional space? Maybe I could have done something like this, right? Maybe I could have done something like this, and then my data point will lie in between here. But if I have another data point, or if I select another column, then maybe that column will also have another. So maybe this one will be my Y, this one will be my X, and then this one will be my Z. Okay, so this is X, and then if I have another data point, then that will also lie here. Okay, but I want to plot maybe 3 columns. So over here I'm plotting 2 columns, which is defense and attack, right? So I want to also add another column, right? And in order not to do this in a 3-dimensional space, right, in order not to go into a 3D space, right, I can still do the same thing in a 2-dimensional space, right, without adding a 3-dimensional space. Okay, without adding a 3-dimensional space, I can still do the same thing. Okay, and what this Seaborn will help us to do is to add this hue over here. Let me open this one and show you, right, is to add, let me zoom in a little bit, is to add this called hue, right? So over here is the same thing, SNS lm plot. I have my x, I have my y, I have my data that I supplied, my fit underscore reg, that is going to take away the regression line. And then what I'm adding here is this hue, right? So I'm using that hue equals legendary. Legendary is another column, right? So if I show you up here, right, if I show you up here, let's go and see. You see that we have legendary here, right? You have legendary, which contains true or false, right? So legendary is another column. So in order for me to also add legendary, right, so that I'll still plot it in the two-dimensional space, I can use color to actually do that, right? And so that's the function of this hue. Hue will help you to differentiate, or help you to plot in a three-dimensional space on using just two-dimensional space, right? Using this hue is just using colors to actually help you to plot in three-dimensional space, bringing three-dimensional space into two-dimensional space. That's what I want to mean. All right, so hue will help you to actually bring three-dimensional space into two-dimensional space to make the visualization possible, just using colors. Okay, so you can see that it's using the blue and then the yellow here, where the false represent blue and then the true represent yellow here. So you can see that there's a lot of false as against true. So if I do this, let me show you. If I do our data, right, and then in our data I select this legendary, I select this legendary, I think is here, right? Then I do value count, value underscore counts, right? If I do this, now you can see that we have 147 false as against only four true. That's why you can see here, you can see here 1 2 3 4, right? Only four true that you can actually see, only 4 true that you can see. But you can see that if we were to be able to count the blues, you can see that there will be 147 of them. Okay, so although we are seeing the correlation that is existing between defense and attack, we are also seeing the distribution of legendary, that is the false and then the true, right? Legendary contains false and true, right? The legendary column contains false and true. Don't forget that we are just seeing the first 5 rows, right? We're just seeing the first 5 rows over here. Okay, so it contains, there are some truths in there. If we are to go a little bit down, maybe if we say 20 over here, right, and then see, we might be able, okay, still now we are not able to spot true, but because they are very small, only 4 of them, right, only 4 of them, so it's quite difficult to spot that. Okay, but there are some true in there, but they are very small, only 4 of them. So you can see that we are still be able to see the distribution of legendary alongside the correlation that is existing among defense and attack. Okay, so this hue will actually help you to do that. All right, hue will actually help you to do that. Now let's see what we can actually do over here, right? So let me bring this one and then see how we can actually do over here. Okay, over here I'm going to use the Matplotlib again, right? I'm going to use the Matplotlib again. Now I'm going to show you how you can explicitly, now remember that when we're doing the Matplotlib, right, these axes 0 to 100, right, automatically it will give it to you, right? It will give it to you automatically. If we don't specify, then it's actually going to give it to you automatically. Okay, you can actually specify that if you want to set your own index. All right, you can actually do that. Okay, you can actually do that, and I'm going to show you how you can do that. Okay, so what I'm adding over here is this, right, is this fig.add axis, right? That's what I'm adding here, right? And then I'm storing everything in a variable called a1. Okay, now inside here I'm having these values in here, right? These are just values to just change the size. So if you see this, the colon signature of add axis is just it's where rect is a list, right, which is x naught and then y naught with a width and then the height, right? So with a width and then the height. So we have a width and then the height here. So if you see this one that I have here, if we want to change it, maybe I can change this to say 5, or maybe let me make it 10 so that you see the difference over here, right? So that you will see the difference. So if I run it again, you can see how this has been. So now it's so big, right? You can see how it has been, right? It has been. So now I'm having 10 at the length, right? And then the width, right? The width as 7, right? So let me reduce it again, right? So earlier when I was having just 1, okay, having 1, 1 here. So if I run that again, now you can see how small it is. So that's what this one is actually doing, just setting this, right? Setting the sizes over here. That's what it's actually doing. Now over here, what I'm doing is that I'm generating this. Remember that we did this in the NumPy class, right? We use this arrange function to generate numbers between the specific input that we will give here. So in this case 1 to 10, right? So we will be having 1 2 3 4 5 6 7 8 9, right? I mean starting from 1, right? Because we are specifying that it should start from 1. So if I should just run this, only this one, for you to see the output that we have over here, right? If I should do that, you will see that. Right, if I do this, you see that we have 1 2 3 4 5 6 7 8 9. All right, so that's what I'm actually specifying over here. That's going to be my x values. Okay, that's going to be my x values. So that's this point that I'm doing. So after that, what I'm going to do is that I've already set the size that I want. Okay, so I'm going to use that where I stored it in A1, right? So I'm going to use A1.plot, right? Then I pass in my x, which is the x values that I've created. Don't forget that I need to pass in x and then y. Okay, so for y values, what I'm going to use, that I'm going to use exponents, right? So exponents of this, right? I'm going to generate exponentials of the numbers that I have in x. Okay, and this b is nothing but the color, right? So if I said b equal, if I do this, if I use just b, that is going to give me blue, right? If I use say r, right? If I use say r, is going to give me red, right? So over here now you can see that we have red, right? We have red here. All right, so we're having b as blue, right? If I do b again, right, you see that we have this as blue. So that's what this b is actually doing. Okay, then I'm setting the title. So a1.setTitle, range of numbers, right? So the title should be range of numbers, and that's what you can see over here as range of numbers. Okay, now what I want to actually show you is that you can actually set this. You can set this, right? This axis that you can see here, you can actually set them, right? So on the y limit, right? On the y limit, so these ones automatically will be generated for us. But in this case, I want to set this limit manually. Okay, so I want to set it from 0 to 10,000. So the highest here should be 10,000. So you can see from 0 all the way to 10,000. All right, from 0 to 10,000. And then on the x limit, right? On the x limit, I want it from 0 to 10. Right, that's what I'm specifying here. From 0 to 10. Okay, so I can do from 0 to say 20, right? And if I do that, you can see that I have from 0 to 20, right? I have from 0 to 20. I can do from 0 to 15, right? I can do from 0 to 15, right? So you can set the size as you want. You see that it's starting from 0 to 14. It's still 15 numbers that have been generated for me. Okay, so that's what you need to note, that you can actually manually set these. Right, you can manually set this. Then over here I'm setting the x label and then the y label, right? So x label, I want it to be x-axis, right? So that's what you can see here, x-axis. And then the y label, I want it to be y-axis, and that's what you can actually see here. Then I'm using the plt.show to actually show my plot. Okay, so you see how many code that we've been writing over here just to do this, right? So this is Matplotlib for you, right? If you want to really use Matplotlib, is kind of sometimes it becomes a bit hectic, and you'll be writing a lot of code, right? Unlike this one that we just wanted to do this, right? we're using this SNS to just do this, and we're able to generate these plots, right, as easier as possible, right? We're able to do this. This one is actually a PLT that we use, which is Matplotlib, but when we're using the Seaborn, right, it was just as simple as that's just a single line of code, and then we are done. Okay, unlike this one, that if you see what we've been able to write a lot of lines of code, right, just to plot this, right, just to plot this. So I just wanted to show you this so that you know, if you just want to use the core, Matplotlib is awesome. It's quite awesome, but if you really want to get around this and make your code as fast as possible and as simple as possible, then I recommend using Seaborn. Okay, and Seaborn is still built on top of Matplotlib, so you still get the functionalities of Matplotlib. Okay, so we're done with that one. I'm just showing you the header for data, which is the data that we've been working with so far, because down here we are actually going to work with this data again. So I don't want to be scrolling up here and then go and show you again. That's what I'm bringing it here, right? So now what I'm going to do is to use the Seaborn. Now see, if any time that I'm using Seaborn, it's just one line of code and it's done. Okay, just like that, as simple as that. Okay, and I'm setting the figure size over here as we've already discussed about this. So figure, and then the figure size 15 by 15. Okay, 15 by 15 over here. So if I do that, right, don't forget that I'm using Boxplot over here. So if I'm to use the PLT, right, which is the Matplotlib, maybe it's actually going to take a little bit of time, me coding a lot of lines of code, just like we're seeing something like this, right? But with this Seaborn, we are able to just use this Boxplot function to do that. Okay, so if you run this, right, now you can see what we have here. Don't forget I'm passing in all my data, right? I'm passing in all my data here. Okay, and what it's going to do is that it's actually going to plot this. It's actually going to give me this box plot. Right now, one thing that we can notice here is that if we take this total, right, total is nothing but if you see the total column, right, it's having huge values, right? 318, 405, 525, 309, 405, all the way to the last one that we could have seen, right? If we see the tail of this, right, if we see the tail of this, which is the last 5 rows, right, if we see the tail of this, you see that we have 300, 420, 600, 680, 600. So these are huge values that this column contains. That's why you can actually see that one being so strange over here. Okay, that's what you can see. So you can see the maximum is somewhere closer to 700, right, and the minimum is somewhere a little bit below 200. Okay, so you can see that's how it's actually making this scale unreasonable to actually see, because there are some which are having high values, there are some too which are having very low values. If you see, say, stage, for instance, stage is having just 1, 2, 3, 1, 1, right? So it's actually having very low values, right? So it's supposed to actually be somewhere there, very low values. All right, that's why you're actually seeing some inconsistencies in here. So what we can do is to actually take off this and then take away these, right, which are not of the same scale as what we have here. Now if you see what the data points that are made in the middle here, HP, attack, defense, ATK, and then def and speed, right, if we see them in HP, attack, defense, ATK, def, speed, they all having values which are around say 50, 80, 100, right? They are all having similar values, right? They are all having similar values, right? They are all having similar values, right, from HP to speed, right? They're all having similar values. That's why you can see their box plot is a bit similar to each other, right? Because their values are a bit similar to each other. Okay, so we can actually take off this and then take off these two. Okay, so that we'll have a beautiful Boxplot. So that's what I'm going to use. I'm using the drop function. If you remember this in the Pandas class, you can actually drop some of the columns, right, using the drop function. So I'm going to drop total, I'm going to drop legendary, I'm going to drop stage, right? So I'm going to drop total, right, this one, then I'll drop stage, then I'll drop legendary. So that's what I'm doing. Then I'm specifying that what I want to drop is present in the column that is axis equals 1, right, which showing Pandas that what I want to drop is in the column, right? So if you do axis equals 0, it means that what you want to drop is actually in the axis or in the row. So if you use axis equals 1, it means that you are telling Python that specifically NumPy that what you're dropping is actually present in the column, right? So if I use here, if I specify 0, it's actually going to give me this error saying that total, legendary, and stage cannot be found in the axis, right? It means that it's actually going to go into this row and then see if it can find total, legendary, and speed over here, which is not true. They are found here and not here. So I need to specify that, right? I need to show this one as 1, right? I need to show this one as 1. Okay, then if I run, let me undo this. Okay, let me undo this, and then I'll do this because I've run it before, so I don't want to actually run it again. I have actually dropped it before. Okay, so now you need to take care of that and then see that you specify that axis equals 1. Okay, now if we do that, we're going to actually plot it again, right? We're going to remember that we drop it, so everything that is left, we store it in a new data, which is our data 1, right? So our original data is named as our data, right? So we are storing, after we drop this, whatever is left, we want to store it in a new variable called our data 1. So that's what you're going to work with right now. So over here, I'm still going to plot this box plot, but and I'm specifying this figure size to be 15 by 15, right? So if I do this, if I do that, you see what I have, right? So now I have only HP, attack, defense, ATK, def, and then speed, right, which are these ones that were in the middle here. Okay, that way in the middle, that way having same scale as each other. So that's what I'm doing here. Now you can see how the box plot looks. They're having a bit of uniformity among them. All right, they're having a bit of uniformity among them. So what I can do over here is to also check the correlation that is existing among these data points, right? So the correlation that is existing among this HP, attack, defense, ATK, def, and then speed, right? I can check the correlation that is existing among them. So in that case, I'm going to use our data1.call. So in order to check the correlation, we use this call function, right? There's nothing but correlation, right? That's a Pearson correlation. So I'm going to use that. So if I do that, right, this is the output that I get, right? This is the output that I get. Now, if you can see over here, right, maybe we can actually spy something, right? We can spy something here. Now, if we take, say, the speed, right? If we take the speed, for instance, we can see that if you want to say maybe the speed and then the HP, right? What is the correlation that is existing among the speed and then the HP, right? So for that, we can actually trace that, right, and then see the correlation. So it's actually this, right? It is this one, which is negative 0.04, right, which is negative correlation, but it's very less, right? So this one will be a moderate, right? It's actually going to be a moderate negative, right? Moderate negative correlation, right? Just like we saw it up there, right? That's what it's actually going to do. Okay, and then you can actually see it. I mean, pick any of them and then compare. For instance, if you want to compare defense and then say maybe defense and def, right, we can actually do that. So if we trace this, right, and then trace this, you see that it's this one. So defense and def are positive correlated, right? They are positively correlated. Okay, and it's actually low. If you can see 0.1, right? So if it's closer to 1, right, if it's closer to 1, then it's high, right? If it's closer to 1, then the correlation is actually high. Okay, but if it's closer to 0, then the correlation is low. right? So if it's closer to 0, then it's low. If it's closer to 1, then it's high. Okay, then it's high. In this case, we have 0.1, which is closer to 0, right? So it's actually a low correlation, right? And then we have negative 0.04, which is very close to 0, right? So it's, although it's negative correlated, but it's very low negatively correlated. Okay, very low negatively correlated. All right, so you can do the same for any of the output. For instance, attack, and then defense. You can see that 0.49, right, which is still low, right? If it is above 0.5, right, 0.56 or 0.6, right, 0.6 and above, then, or basically you can use 0.5 and above, right? Then you can say it's high, right? But if it's below 0.5, right, below 0.5, then you can say that the correlation is low. Okay, you can make that you can actually say that. Okay, so what we can actually do over here is to use what is called the heat map, right? What is called the heat map to actually visualize this, right? To actually visualize this. So it's the same correlation that we are seeing here, the same thing that I'm using the heat map function to actually plot it over here. Okay, so what the heat map function is actually doing, setting the figure size, right? So this one we already familiar with, and then over here I'm using sns.heatmap. Okay, I'm using sns.heatmap. So this heat map is present in Seaborn. If I want to use Matplot to do this, there's going to be a lot of lines of code, right, to do this. But Seaborn, on just a single line of code, we can actually do this. Okay, we can actually do this. So I'm passing in this call, which is the correlation that we did here. Remember that we find the correlation among these data points, and then we store it in what the variable called call. So I'm passing that in here, right? I'm passing that in here, and then I'm using the heat map function to plot that. Now if we look at this heat map, right, what is actually telling us that just see the bar that we have here, right? Let's see the bar that we have here. Okay, now what this bar is actually telling me is that I have 1 here, right? I have positive 1 here. Maybe I should change this one. I have positive 1 here, right? I have positive 1 here. Then I have 0 here, right? So the more we go up, right, the more the color becomes lighter, right? The more the color becomes lighter, the higher the correlation, right? The higher the correlation, and the more the color becomes darker, right, the lower the correlation, right? So if you take, say, HP, right, if you take, say, HP and then speed, right, HP and speed is having a very low correlation. That's why the color is actually deep. Of course, the diagonals, right, if you pick the diagonals, it's going to be very light because it's just a correlation among itself. For instance, if you pick this say attack, right, this one lighter one that you see here is just attack and attack, right? Attack and attack. That's a correlation among itself. So a correlation among a variable and itself is always going to be 1, right? It's always going to be 1. It's always going to be a perfect correlation, right? And actually on the normal or on the real world, we don't actually measure correlation among a data point and itself. It doesn't actually make any sense, right? What we do is that we measure the correlation among a variable and other variables, not a variable and itself, right? So that's what the diagonals are actually going to give you. It's actually going to be a very light color, which showing a very high correlation. That's a perfect correlation of 1. Okay, but actually we don't do that. So what we want to actually do is to measure the correlation between say attack, right, between say attack and HP, okay, or maybe defense and attack, okay, or maybe def and then defense, something like that. Okay, now if you're considering this, right, let me actually show you down here. Right now this one will make a little more sense, right? This one will make more sense. You see these numbers that we have, right? When we check for the correlation, right, our data.core, we got to know the actual correlation. So if we pick say attack and say defense, we saw that we know that the correlation that is that is existing among attack and then defense is 0.49, right? That's a positive correlation, right? But over here we're using color to do that, but we don't actually see the real correlation, but we can infer this based on the color that we have. We can actually show these, right? We can actually show these numbers on this, right, on that. So in order to do that, what we can do is to use this annotate equals true. It's nothing but annotation, right? This annotation is nothing but what you annotate on, what you show on this heat map, right? So we are saying that it should be true. If you set it to false, it's not going to show, right? It's not going to show. I mean, by default, right? By default, it's actually set to false, so it's not going to show. But if you can specifically specify that the annotate equals true, so that it's actually going to show that. Now if I do this, now you see that we have those numbers on top, we have those correlation on top. So if you see, if we pick for instance defense and then attack is 0.49, right? So let's go and see, right? Defense and then attack, right? Over here, defense attack, right? Defense attack, right? So you see that is 0.49, right? If I should draw this one for you to see, right? So defense and then attack, right? Defense and attack over here is 0.49. It's just the same thing that we're seeing over here. The same thing that we're seeing over here, right? The same thing that we're seeing over here. Defense and then attack, right? Which is 0.49. Okay, so we can actually annotate this one on the heat map, right? So we can have a better view here. We can actually have a better view of everything that is happening over here. So if we pick any of these data points, we can actually see their correlation. Now, if you're seeing the correlation, one thing you need to note when you're dealing with this heat map is that the diagonals are going to give us 1, 1, 1. As you can see, that's a perfect correlation, right? Now, whatever information that the top, this top here, right? Whatever information that you are getting here is the same information that is represented here. Okay, so you can either use either half of the heat map to actually make an inferences. For instance, if you pick this 0.13 here, it's the same that you can see here, right? 0.12 is the same thing here, 0.49 here is the same thing here, right? 0.15 is the same thing here, 0.19 is the same thing here, right? This one 0.37, right? So let me see where it is. It's here, right? This one, that's one, okay? This one, that's one, okay? This one, that's one. So they are all the same thing. They are all the same. It's the same information that you can find at either half of it. So you can just use one half of it and then make the inferences, right? You can use one half of it and make the inferences. So you can forget about maybe this part. Anytime you plot a heat map, forget about the other half. You can forget about the down or forget about the up, and then use the half of it to actually make your inferences. Okay, so over here I can see the attack, right? Attack, and then attack and HP, right? Is they're having positive correlation, which is 0.31, right? Although it's low, but they're having positive correlation. Okay, and you're going to use this over and over again. So if I show you this, right, if I show you one here, you see that I plotted over here, right? So this is one of the projects that you'll be doing, right? You see that I'm using a lot of box plots over here, right? I'm using a lot of visualizations over here, okay? And if you see over here, I'm using PLT, right? I'm using PLT here, which is Matplotlib, right? And then over here you can see that I'm using SNS, which is Seaborn. Okay, so whatever I'm showing you here is something that you're going to need moving on, right, to do in order to be able to accomplish your project, and in order to work in any other real world project, you're going to be needing all these, right? That's what I'm showing you. Okay, so take note of them as we progress. Okay, so let's go back to what we were doing. All right, so we've been able to plot this, and then we've been able to also show these annotations on top of it. All right, now let's actually move on and then see what we are dealing with and what we can actually